So welcome to part 2 of C fundamentals. Part 2 of C fundamentals. This session will discuss about data types. Data types. We consider computers. For what purpose computers are designed? For what purpose computers are designed? Or why do you use computers? Why do you use computers? Computers are basically data manipulation devices. They manipulate the data. Computers are basically data manipulation devices. So usually we work on two types of data. One is numeric data like numbers. They can be integers, they can be real numbers. And we also work on the characters, group of characters. Okay. So basically we manipulate what is called as data. Basically we manipulate what is called as data. Now, how do you represent that data inside a computer? How do you represent that data inside a computer? Now, how do you represent it using C language? How do you represent it in a C language? So what are the data types that are supported by the C language? What are the data types that are supported by the C language? When to use different data types? When to use different data types? Those things we are going to discuss in this session. So more appropriate definition of data type. I am calling it as more appropriate definition. Because if you consider the data type definition that is given in many books, data type definition that is given in many books, according to me, it's not correct. According to me, they are not correct. They are not correct definitions. They just mention the type of values. Data type is type of values. It's not just the type of the values. We have to consider correct definition, and usually you find this definition in the programming languages related books. Principles of programming languages, fundamentals of programming languages, like that. So you have different books. So in those books you find this definition of a data type. So the more appropriate definition of data type is the domain of values and the set of operations that can be performed on those values. Domain of values and the set of operations that can be performed on those values. Both are defined. Both are defined. Domain of values and the set of operations that can be performed on those values. Say if you take 10, 20, if you take 10, 20, they are generally considered as integers. So whenever we talk about integers, so there will be a domain of values. What are the possible values? What are the possible values? If we consider floating, the possible values can be 12.5, 13.5, 20.0, etc., etc. Okay. So the domain of values, what are the possible values? What are the possible values? And also the operations that can be performed on those values. Suppose if you consider numeric types, you can perform addition, subtraction, multiplication, division. But if you consider, say, finding the remainder, you try to find out between the integers, but you don't try to find remainder with respect to real numbers. With respect to the real numbers. Okay. So you can approximate it, but it is generally we don't do it. Generally we don't do it. Similarly, if you have these, say, characters A, B, C, etc. So you don't add characters. If you store some values, if you use A and B as variables, then you can add the contents of A and B. But if A and B are just simply characters, you don't add them. You just don't add them. So the set of operations are also defined. That is the main point. Domain of values and the set of operations that can be performed on those values. Both together define a data type. C language, we can classify the data types into three types: basic data types, derived data types, and then user defined data types. Basic data types, derived data types, user defined data types. So we'll see one by one. So basic data types are the fundamental data types supported by the language. Language itself supports those data types. So you can directly make use of them. They are basic, fundamental in nature. So any data type will be redefined or user derived from these data types only. Redefined or derived from these data types only. So they are fundamental. So without them, programming language cannot survive. So are those that are defined by the language itself. Okay. Derived data types are those which are derived from the basic data types. They 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 are derived by combining one or more types. So whatever the basic data types that are available, you can combine them. Of course, how you combine is also defined by the language. There will be some limitations, but you can combine them. And derive what are called as new data types. In simple terms, say record may consist of roll number, name, etc. Okay, so the roll number may be integer type. Maybe you can say this name can be a character type. Actually, character type, it will be a collection of characters called as array. We'll see it later. But all those things can be combined. These basic data types can be combined, and you can derive the new data types. That new data type may consist of collection of items of the same data type or combination of different data types. So it will be a collection. You can say it will be a collection consisting of items, and all the items can be of same type or different types. The next one is user defined data types, or those which are defined by the user. Actually, you cannot create new data types. The language, you cannot create new data types. Okay, so but user can define them in the sense that name can be changed for convenience. Why name can be changed, what is the necessity, we'll see later. But user can define his own data types by giving appropriate names using what is called as type def construct of the C language. The basic data types supported by the C language are integer, the basic data types supported by C language are integer, float, double, char. Integer actually represented using int only. Int, float, double, char. So int stands for integer, whereas float and double stands for actually real numbers. And char for characters like A, B, C, D, etc. The latest C standards may support other data types also. For example, Boolean is also supported in the latest version. So examples of derived data types are array, structure, union, function, pointer. So array, which is a collection of data of same type. Structure, which is a collection of data of different types. Similarly, the case with the union. Then function and pointer can also be considered as derived data types. So many books doesn't mention them as derived data types, but they can be considered as derived data types. But each of these we'll discuss as a separate chapter actually. Each of these we'll discuss as a separate chapter. So we're not going to the details. Next, type def can be used to create new data types. Like type def. See here, type def, original data type, new data type. Original data type, new data type. Say, for example, also we are going to discuss later, but one just example. Type def, say original data type integer, roll number. So you can define like this. That means instead of integer, now we are calling it as roll number. So we can declare roll numbers now using this roll number data type. Roll number R1, R2 like that. So we didn't cover yet these declarations, but you can declare the. So we discussed about this. Discussed about this int a comma b comma c. Now suppose now the ABC represent the roll numbers. So after declaring like this, you can write instead of integer roll number a comma b comma c. So like this you can define. So basic data types, derived data types, user defined data types. Void can also be considered as another data type called as void, which has no associated values or operations. So voice is generally not considered as a separate data type, but nevertheless it represents whether there is some valid value or not. Whether there is some valid value or not. So it is generally associated with the functions. We'll see how to use this void to indicate that function doesn't return anything. And also it is associated with the generic pointers. So to create generic pointers, we use void. The size and bytes of each data type may vary. And the range of values the variables of this type takes may vary from implementation to implementation. So size of each data type, how much size integer occupies, how much size float occupies, double occupies, that may vary. Whenever you are doing programming. If necessary, probably you have to verify it. There is a way of verifying. We'll see it. Moreover, qualifiers, modifiers also change the size and range of values. Qualifiers or modifiers also change the size and range of values. What are the qualifiers? What are the modifiers? We'll see in the next slide. So these are the basic data types. Char, int, float, double. So as the name indicates, char is used to represent a single instance of a character. Okay. So it occupies only one byte. That too 7 bits. But nowadays 8 bits is also used. 8 bits are also used. Okay, that table is actually called as extended ASCII table, extended ASCII set. So we are not going into those details now. But just remember, char represents a single instance of a character, like A, B, C, D, or it can be 0, 1, 9 digits also. Integer occupies 2 bytes, and int represents the integer data type. The range of values it represents is -32768 to 32767. Similar the case with the float and double, which are for representing real numbers. Float is for single precision, double is for double precision. That means the precision value is going to change unless you are working on numerical data types like sometimes weather forecasting related applications, etc. You need not bother too much about the difference between this float and double. Only thing is, if you want more precision, go with the double. Double. Technically, there will not be any difference. except that precision. So float occupies 4 bytes, double occupies 8 bytes. Floating point supports 6 digits of precision, and double it's not doubles, double support 14 digits of precision. That means the digits after the decimal point, 6 digits, 14 digits. Modifiers or qualifiers, so they augment the meaning. They augment the meaning of the basic data types. So they augment the meaning, and automatically the size and range of values also changes. 4 modifiers are supported. 4 modifiers are supported: short, long, signed, and unsigned. Short, long, signed, and unsigned. So integer can be signed or unsigned. That means positive and negative values are permitted, whereas float and double are always signed. So when signed representation is used, the most significant bit is reserved for representing sign. 1 can represent say plus, and 0 can represent negative. Okay. So when sign representation is used, the range of values becomes half. Sign int represents the values from -3 to 7682 plus 3 to 767. Unsigned int represents values from 0 to 65535. So here, if you observe carefully, so the range of values is going from -3 to 768 to 67. So why this one more negative number means? It depends on the representation, signed representation, how the computer actually represents them. There is signed representation, one's complement representation, signed representation, one's complement representation, and two's complement representation. Because computer generally uses this two's complement representation, you get one more value. One more value is possible. We will study about it in a computer organization in detail, but for the time being, you observe the difference. And signed bit is also required. If you want to represent signed numbers, it's not enough if you write just plus, minus, etc. Internally, when you represent inside a computer will not understand what is plus, what is minus. Okay, everything has to be told in the form of ones and zeros. So if 8 bits are there for representing any value, if 8 bits are there representing any value, in the case of unsigned representation, 8 bits are used. 8 bits are used for unsigned for value part only. So in the case of signed representation, if 8 bits are available, 1 bit is used for sign. That means 1 bit means it can be 0 or 1. So there will be some convention. So 1 can represent positive, 0 can represent negative. So that means only 1 bit is used for sign, and the remaining 7 bits are used to represent the value. Okay. So because you are using 1 bit for the representing the sign, the number of values definitely changes. Approximately it is half. That's why here you can see sign int occupies if it is sign int, reference values from -3 to 7682 plus 3 to 767, whereas if it is unsigned int, then 0 to 65535. So whenever you don't bother about the sign and if you deal with only unsigned numbers, then you have to explicitly mention it as unsigned. How to mention all those things we'll study. Okay. So by default, if you don't specify anything, whether it is a signed representation or unsigned representation, it will be signed representation only. The qualifiers. The qualifiers are there. What are the qualifiers? Short, long, signed and unsigned. We discussed about this qualifiers, signed and unsigned. Now short and long. So the qualifiers short and long can be applied to all basic data types except char. So the size and range of values when qualifiers short and long are applied may vary. The general rule is like this. Size of char less than size of short, less than or equal to size of integer, less than or equal to size of long, etc. etc. So you can use these qualifiers short and long. So generally you don't use the qualifier short. Generally we don't use the qualifier short. So it's not necessary most of the cases, but now and then we'll be using this long. Long means whenever you want to store more values, range of values is high, then you go with the long. For example, whenever you are computing this factorial function, factorial of a number, it's better you go with the long. So remember, you can store more values or large values in this long type. So if you want, you can just check the data type size. Here you can see even here. Okay, this long occupies more amount of memory. Long occupies more amount of memory. Long occupies more amount of memory. We'll try to actually print the values also through a program. So the general rule is short int occupies less memory or same amount of memory as that of integer. Long int occupies more memory than that of integer or maybe equivalent. So again it varies. So usually if integer occupies 2 bytes, short also occupies 2 bytes, long occupies 4 bytes. So unsigned qualifier can also be applied to other qualified integers. If you want, you can use it. So in C language, char can be stored in an int data type. That point please note down. So in C language, char can be stored in an integer data type. So that is permitted only in C language. Some compilers permit the qualifier long to be applied to float or and to double also. They write long float, long double. So these things please try to remember. The takeaways here are only this, that there are the data types called as int, char, float, double. That please remember. You don't try to get too much into the range of values, etc. We are not going to work on any numerical problems where high precision is required, etc. Okay, that we are not going to do. So, and also this long is useful sometimes. Just remember that. Thank you.